Today we're going to be looking at 8.4, which is polar coordinates. So here's our definitions and stuff. So what is a polar coordinate system? A plane with a point O, called the pole, and a ray from O, the polar axis. And usually we're going to coincide that with the x-axis, positive x-axis right there. So usually this is the origin, and this would be the positive x-axis. Okay, this is called a polar axis. Each point in this plane is assigned polar coordinates, which represent the radius and then the angle. So what they're basically you're doing here, instead of going like x and then y, we're going to go at an angle, and then we're going to move out a different length, r. So we go to an angle, and then we walk either forward or backwards accordingly. R is the direction distance from O to P. Theta is the direction angle, whose initial side is the polar axis, and whose terminal side is this ray OP. So that's how we're going to graph these things. And some things to keep in mind. If the angle is positive, we're going to go in a counterclockwise direction. Negative is in a clockwise direction. R, if it's positive, we turn to the angle and we walk forward if R is positive. We turn to the angle and walk backwards if R is negative. Okay? That's what that's saying. So we're going to do some examples here about how to plot some points in polar coordinates. So I have a couple over here. Let's just look at those right there. So here's a R and an angle. So the first thing you want to do is you're going to put your little pole, and this is the pole axis. And we're going to go to angle 4 pi over 3. So 4 pi over 3 in our unit circle aspect of things, we know is down here. So this is the angle 4 pi over 3. So there's my angle. And so now the question is, now I need to walk. So I'm still standing here. I'm facing along this line, and I need to walk to 3, a distance of 3. So I walk on this line right here, and I stop when I have gone a distance of 3. And so that's the name of that point right there. Okay? Let's look at this one over here. Again, here's our pole and our pole axis. We need to go to angle 135. So 135 is basically the 45-degree angle in this quadrant over here. So this angle right here is 135 degrees. So I'm standing here and I'm facing along that line. But the R is a -2. So what that means is, extending back in this direction, I'm not going to walk forward, I'm going to walk backwards until I have a distance of -2. So this point is -2, 135. So you turn to the angle, and if the R is positive, you walk forward, and if R is negative, you walk backwards. And so that's how I graph points. So some additional notes right here. This is the same thing I just said. Each point in a polar coordinate system is unique. So that point is unique, but there's many ways to get to that point. Okay? Because this is polar and it's a circular action, just like our unit circle, there's an infinite many coterminal points, lack of a better name. The same thing applies here. If I do different angles, but all the angles are terminal with this 135, then I can keep getting this value down here. Right? So we're going to look at how do I get some different points that represent the same point, some different coordinates that represent the same point. So, find all the polar coordinates for this point. 1, and then negative pi over 4. Okay? So doing the same thing we did before, we're going to draw our picture. So here's the pole. Here's the pole axis. I'm going to go to negative pi over 4. So it's a negative, so I'm going in a clockwise direction. And it's going to be this one right here. So this angle right here is a negative pi over 4. And then I'm going to travel a distance of 1. So since I'm facing this direction, I travel in this direction. Put a dot. This is B1 negative pi over 4. That's a distance of 1 right there. Okay? Using this as a reference, what are some other angles I can have that get me to the same terminal place? One of them would be if I, instead of going in a negative direction, if I went in a positive direction, that would be one angle I can use. Okay? So what is that angle right there? Well, if I take this point, 1, negative pi over 4, and add 2 pi, there it is again, then I'm back to here again. So what is the name of that angle? Well, that's 7 pi over 4. So that is another way to express the same point. Well, what's another way to do it? Now, again, I can go around a second time, a third time. These are there's an infinite number of them. But this is just one of them. The other way to look at this point right here is using a negative r. So if I extend this line right here, this angle line in both directions like so, the other one would be if I went to this angle right here, so that angle, and walked backwards. So if I do that angle and walk backwards, well, how do I get that angle? Well, it's this angle plus pi. So, and then if I want to go down to 1 this way, because I'm facing forward this way, then I need to walk backwards, which means I need to use a negative 1 for r and take this angle and add pi. So that means I'm going to turn to this angle and walk backwards 1. That's another way to get to that point. So these are the two main ones that you're going to learn how to write. Okay? So the angle here is 3 pi over 4, and then walk backwards, negative 1. Okay? So that's how you can do that. Here it is in general. So what they're showing here is this. Take this angle right here, and I get as many as I want by adding or subtracting 2 pi times n. Here's that angle, and add or subtracting 2 pi n on that one, where n is your counter, 0, 1, 2, dot, 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 just like before. And then here it is in general down here. It's really kind of blurry. I can get to zoom in better. There we go. So here it is in general, what we just set up there. Okay, so let's continue on. The other thing you need to be able to do is be able to convert. Sometimes we have polar, but we want to go back to rectangular or vice versa. So here is the conversion between polar and rectangular coordinates. If I do this as an XY axis, where the pole axis is the x-axis, the pole is at the origin. Here is this r. This point as a polar is that, as a rectangular is that. So what is the connection between all these things? Well, it's going to be a familiar connection that we've seen already. The x, the cosine of theta, is x over r. So if I solve for x, I get that. The sine of theta is y over r, so solving for y, I get that. So these are the conversions between x and y. because I have a right triangle here, r squared is related to x squared and y squared by Pythagorean theorem. And I can represent the angle using the tangent definition, y over x. So we use these things to convert coordinates into the other format, back and forth. Okay? And so we're going to do this example right here and show you how to do that. So this is a polar coordinate, and we're going to change it to a rectangular coordinate. So this is r, and this is theta. Okay? So with that information, I can come over here and I can work this out. So r is 3/2, theta is 7 pi over 3. And so I can just simply find x, which is r times the cosine of theta. So this is going to be 3 over 2 times the cosine of 7 pi over 3. And y is going to be r sine of theta, which is 3 over 2 times the sine of 7 pi over 3. So it really just boils down to is where is 7 pi over 3? Okay? What quadrant is that in? And all that kind of stuff. So you can do your little unit circle action here. One time around the circle we know is 6 over 3. And so the next one up is 7 over 3. So we're right here is equivalent to pi over 3. 3/2 times the cosine of pi over 3, which is 1/2. And then this one is 3 over 2 times the sine, which is the square root of 3 over 2. So when I work this out, I get 3/4. And work this one out, I get 3 times the square root of 3 over 4. And that is my x and y coordinate system. And that's how you put it into rectangular coordinates. Okay, I have another example that goes in the other direction. Let's change this one, 0.13 in rectangular coordinate system. Let's change it to polar coordinates. So x is 1, y is 3. Okay, so if x is 1 and y is 3, I can find the r using r squared is x squared plus y squared. So r is the square root of those. And so r is plus or minus the square root of 10. Okay, don't forget to put plus or minus on it. To find the angle, I can use the tangent of theta is y over x. So the inverse tangent of 3 is what theta is. Now remember, anytime you do this, is this a reference or is this an actual? This angle is positive, so it is in quadrant 1, so it is an actual. The tangent is also positive down here in quadrant 3, which is great because that's going to help us coincide with the other angles and such. So because these are both here, we got to use both of them. And this one is the tangent. This angle is tangent inverse of 3. And this one is the inverse tangent of 3 plus pi. So the 0.13 is right here. 1, 3, right? So how can I use these to get that point? Well, for this one, it's pretty straightforward. It's going to be the positive r and then the angle. But I can also get that point in polar by going to this angle and then walking backwards. And that's where the negative square root of 10 comes in. And then you use this other angle to get to the other one. So there is the two polar coordinates that do it. Now, We also want to convert equations. And the process for converting equations uses the exact same relationships up here. So let's do that and show you how this works. Now, in doing this, you're going to need to use trig identities. You're going to need to use algebra techniques. And so the whole point is to get to the point where we can use those conversion factors up here. So I want things in sines and cosines. R's, I might want to use Pythagorean theorem if I need to get R's involved. And so that's what's going to happen here. So this is a cosecant, but I don't want a cosecant. I want things in sines and cosines. Okay, so I can use those conversions. So you're going to do some converting of this thing. So R is at -2 times 1 over the sine. And then you're going to move the sine, multiply both sides by sine, because when I do, I get R times the sine of theta is -2. And I know what that is. That is Y. So this is a fancy way of just saying the horizontal line at -2. Okay? Let's look at this one over here. Again, we don't want fractions involved, so we want to get things out of fraction form. Remember that in a fraction, if I have more than one term, that's in parentheses. Don't forget that. We're going to basically cross multiply here. We get R times 1 plus the sine of theta equals 2. And then I'm going to distribute to R. But that's the Y. So now I have R plus Y equals 2. Separate the Y over here. And now I have that. But I can't have R's and Y's in the same thing. So I need to change this R somehow. The only thing I have to change to R is Pythagorean identity that they have. Okay? Which means I need to make this an R squared. So I'm going to multiply both sides by R. I'm sorry, that's not what I'm going to do. I'm going to square both sides. So I'm going to square this side and I'm going to square that side. So now I have an R squared is this. And R squared is X squared plus Y squared. And that's how I can get rid of the R. You want to expand this out. And simplify where we can, and you notice that the Y squareds drop out. And I get X squared is equal to 4 minus 4Y. And you can try and solve for Y, which would be fine. You can also just leave it just like that. That's fine too. The last one over here is one that looks like that. Let's change that to polar. How would I go about doing this? Well, first thing I notice here is that I have a Y squared. And I got to get things to R's and thetas here. Okay? This is easy. I can change this to R cosine of theta. I can change this also, right? But it makes it more challenging to do this problem. So what makes it easier is to go directly to R. Is if this was an X squared plus a Y squared, I can make that an R squared. So we're going to add an X squared to both sides. I added X squared to both sides. This makes it into a quadratic over here, makes it look nice. And that right there is simply going to be R squared. This side over here, we're going to factor this to see what it comes up to. A lot of times what happens is this is a perfect square trinomial, which means it's going to factor into the same thing twice. And in fact, this does. This factors into X plus 4 squared. Now, the only thing left to do is to change that X, which I know a value for. So this is now R, the cosine of theta, plus 4 squared. Well, if that squared equals that squared, then R must be equal to R cosine of theta plus 4. These both have an R in it, so we bring it over. We factor out the R, I'm going to get r times 1 minus the cosine theta. Then I can divide by r. I'm sorry, by this right here. And I'll get 4 over 1 minus the cosine of theta. There you go. And so there's a lot of little algebra techniques that are involved, and also some trig stuff that you need to be aware of as you do these problems. We'll do more problems together in class, and that's it.